Good morning. It's a daily quiz, episode 59 on time-weighted averages. It's December 4th, 2025, and people are saying they're getting about 2 of these on ASP and CSP tests. Very rare to get one on the CHSTs, but common on an OHST test. So let's get into it. Safety professionals monitoring worker exposure to acetone during an 8-hour shift. The following concentrations were measured during different work periods: 2 hours at 300 ppm, 3 hours at 200 ppm, and 3 hours at 100 ppm. What's the 8-hour time-weighted average to acetone? 187, 202, 163, 221. Again, the answers won't be within like 1 ppm of it. It'll be far away. And you kind of look at it as like, okay, it's going to be around 200, but because there's 2 hours at 300 versus 3 hours at 100, how does it average out? So let's do the math. You average the 300 times 2 hours, total of ppm in 2 hours. 200 times 3, 100 ppm times 3, 600 plus 600 plus 300, 1500 total, divide by 8 hours equals 187 ppm. Don't worry about the 0.5. Acetone's TWA is 500, so well below the PEL. Let's go to the next one. A little bit tougher. Operators' benzene exposures monitored over a full 8-hour shift. Before lunch, it's 3 hours at 40 parts per million near an open tank, 1 hour at 10 p.m. during a brief inspection task. After lunch, 4 hours at 5 ppm in a ventilated control room. This is what you call like a time motion study. You're timing the area. The answer is A10, B15, C19, D25. Well, you know it's going to be between 40 and 5, of course. And a chunk of it is high. So let's do the math. 3 times 40 is 120. 1 times 10 is 10. 4 times 5 is 20. Divided by 8 is 150 divided by 8, or 18.75, or approximately 19 parts per million. I know people get very excited when it says 18.75, they look for it, but sometimes they're going to round up on these two questions. Not always going to be exactly that ZAB number. The question is benzene, 1 part per million. So you are really 19 times over the benzene standard, so you have to wear a full face respirator with organic cartridges for benzene. That's not good. You kick into the whole benzene standard, medical monitoring, written program, training, and everything else. All right, now we got noise and dosage. This is what people hate in the construction side. If there's anything else they don't want to do, is this noise calculation. You got 4 hours and 95 decibels. OSHA allows you to have, by the chart, if you read the 1910 numbers, 95, you can have 4 hours. 4 hours at 90 decibels, you could have 8 hours. So when we calculate the dose message, there, OSHA uses 5, the industry uses 3, but all the tests are based on OSHA for now. So 95, you have 4 hours, you're at 100% of the dose. That means you're done for the day. But we had also 90 at 4 hours a day, so that's 50%. And you add up the dosage, what's the worker's dose going to be? 50, 75, 100, or 150? Well, it adds up to 150. All we're doing is just adding up the doses in our two segments. 100% dose plus 50% dose equals 150, exceed the OSHA standard of 90 decibels, which is the average. So if you just looked at the question, you could do all day long, 8 at 90. But we have 4 hours at 95. You know the answer is going to be above 100. So right there, we can eliminate these 3 answers. That's it for today. We'll see you tomorrow.